Hello back to our course Procedural Programming. We're now in Unit 3, and yes, you can see already out of this longer list that we have a tough agenda for this video. So step into and have a look what goals we want to achieve in detail. We will skim over very quickly over Hello World and see again the basic structures of a C program. Then we have a big bunch where we go through the basic language elements of C. We will see basic data types, how to do formatted input and output, where you already know how to do output, but input will be maybe new to you. We will see all the control statements which are basically identical to the ones you already know from C#, and finally we'll look into how to define symbolic constants in C. And yes, and finally we will go into the parts of how to define functions. So functions are the counterpart of methods in C. So in C# we defined methods to make our programs easier to read and easier to handle, and in C we have functions to accomplish a quite similar or the same goal basically. Okay, let's start and see into Hello World, and just very quickly you can look into here. This is you know it already, the Hello World program, and so here we repeat the terminology and very basic structure elements of a C program. We start with the preprocessor directive. You maybe remember this. We use it to include an external header file, and yeah, we up to now it's easiest to understand it like like including an external library, a bit similar to the using keyword we know from C#. The next thing is a comment. We have block comment. This means it starts with /star, then is the command which is totally ignored by the compiler, and then we end it with // there is of course also the line command with // again similar or identical to the one we know from C#. Well, there is of course it's not so easy because this // line command is not is not available in certain early standards of C, but we can rely on this. Okay, then we have the main function. This is a mandatory function. We have to have it somewhere in a C program, because this is the one which is called if we start a program written in C. And we know already, so it's pretty similar to C#. There is just the one we have the main method is written with an uppercase M, and we have these arguments, but still we will not look into this. It takes another maybe few videos, and then I'll show you how these arguments are handled and what we can do with them. Yeah, here we have a function call. We're calling printf, so this is an external function, similar again to an external method call. But since we don't have objects in C, we are missing some object or class identifier and a dot, so we can just write here printf, because there is no console object or any other objects in C. So we just write printf. It is defined here in standard IO, and since we include it, we can use it here. Yeah, okay, then finally, yeah, we have to return something. We know here we specified that there is an int return value. So, and by convention, if there is no problem here in the program, we return 0. Good. And then finally, yeah, again, totally identical to C#, where we have the curly braces to enclose blocks of code. Good, that's it. We continue after this, and we go one step beyond and look into the different basic structures and elements of the C programming language. And you maybe see here from this image that we should finally be able to make a very primitive pocket calculator with C. So, okay, go into here. We look into the basic data types. There is the smallest one is a character. Character C. So you remember maybe terminology. This is the declaration of a variable called C, and C has the data type character. This is again totally the same as we have in C#. Now the second one here, we have some kind of a difference. So this is, you see it here, it should be a string. And there is one very important thing to say about strings and C. Basically, a string, as you know it from C#, simply doesn't exist in C. So we have to simulate strings somehow, and we do this by defining arrays of characters. And here is the next thing which is different to C#. The way, so the difference is the way how we define arrays of some type. So you have to read this in the following way. A string is a variable, the name of a variable, of array of characters of the length, string length. And of course, so string length has to be a constant, so any value greater than 0 is allowed. And yeah, and so if we are remembering the C# way to define array of character, we would write something like a string is an array of characters, and we have to initialize this one via new char string length. This would be the way how to do it in C#. So just go back here in C. Things are not that dynamic. You will see later on what this really means. So what we do is we say a string is a character, but it's an array, and we specify this not at the part here where we define the type, but we have to append the array information after the variable. We have to remember this, and well, this is simply a difference, and you have to get used to that. Okay, things are now a little bit more easygoing again. So integer, totally the same as we know, and there are also floats, and there is also no difference to C#, and we have also double precision numbers, which are again the same as in C#. Okay, so these are the basic data types. You see there is no bool, so in different standards there you can't find bool, the data type bool, so we will not rely on this. I will show you in next video how we can overcome this thing. Well, but that's it basically with the basic data types. So then go to output. You have seen it already. We were able to make to write something into the terminal via printf. So we look into this again. Of course, I/O is not part of C, so we need this external library, standard I/O. Okay, and then you know it already, printf. How does it look like? Okay, we have some, so you know already how to write a constant hello world or whatever out into the using the printf function, but here we do it a bit differently. We want to have the name in some string or array of character variable. So we say, okay, we have a variable first name, which is an array of characters of length 64. So means we can store 64, and basically now it's just 63. I'll explain later on why. 63 characters into first name. So this should be fine with Peter, because this is just 5, so there is enough space left. So okay, we do it. First name is an array of characters of length 64 and has an initial value which is the string constant Peter. And so we can write using printf to write this down to the terminal, and we could do it as the following. We could make a format string. This is called a format string here, and we could say, okay, my name is %s, and %s means that here should come a string, and this string, the content of this string, comes out of this variable. So obviously we would write my name is Peter into the terminal into the terminal here. Again, recall and remember how this would be in C#. Here we would write console, write my name is, and here we have again we have something like format strings here again, but the specification of the variable parts is a bit different. We have the curly braces and we have numbers in here, and we could use again the variable having the value that should come into here. So here we have to say we use %s instead of this construct here, and we also specify that this is a string. You will see, if we go further, you will see that we could do something more complex here, but we have to give different format specifiers into the format string, depending on which data type we have. So take this example. This one is clear already. We have an array of characters again, and we initialize it, and we have an integer, we call it score, a variable of type int, and we initialize it by 666. And now we can do this and write out the score of player %s is %d points. The first one is replaced by the first variable, which is a string name, and the second one is replaced by the second variable, score. So then it's easy to see that we would print out the score of player Bertel is 666 points. Good. Here this percent %d says that we expect a digit, an integer digit, to come here. Okay. Now let's go to the input part. You know already that I/O is not part of C, and we know we need an external library. Again, it's standard I/O, and analogously to printf, we have a function called scanf, defined in standard I/O to do formatted input. So to read an integer number, we have to do the following. Consider here an int variable type of operation, and here we do some kind of a polite message what we want to have. So we inform the user that we want to have either a 1 to make an addition, a 2 to subtract two numbers, to multiply a 3, and to divide a 4. And then we say scanf, and again we need a format specifier, a format string with a specifier. We say, okay, we expect a digit, an integer digit, and some type of operation. So we want to have the result into the variable type of operation. And there is just one interesting thing here. What is this ampersand? And you know, in this type of operation is of course a parameter which is not only input. There is a value coming back, a value that is stored in scanf into type of operation. And you know, from C# there are the possibilities to use ref or out. And well, this is the question: is this ampersand now the ref out equivalent in C? Well, nearly. Just keep it as this. We are just look into a few other examples, and then I will explain you what it is really behind this ampersand. Good. More input. Okay, here we want to read a string, but is an array of characters, you know already. we have seen this before, that it's not it's a simulated binary of characters. So we write again a polite message. We'll say, okay, please enter your name, and yeah, okay, first name is an array of characters, and so we say scanf person %s. So we are again similar to printf. We say here we expect a string, and we hand over first name, the array of characters. So floating point, this is straightforward. Polite message scanf %f to say we expect a float, and income. Yeah, %f says here comes, or here should come, a float. And there is just one thing maybe you recognized. Where is our ampersand here? You see, this was no mistake. It is really, it is missing here, and it's here, but here it's back again. So how come? And we'll see this in a couple of slides. I will show you what and why this comes. Okay. Well, but first I want to finish different parts of scanf. So this is our last example. So we could say here, like in this case, we want to have coordinates, for example, and we want to have them inputted by the user in the form x coordinate / y coordinate. And so we write this here, please enter x / y. And we can do again scanf, so f means formatted, and so we can say we are really expecting this format. So %f / %f. So this means two floating point numbers separated by a slash, and then we have to specify both variables which should catch the values entered by the user. So, and if you do this, and so you will get the return value where you can check how many inputs are were be able to how many inputs scanf was able to catch. And if the user somehow mistyped in here, you will not get two inputs, but maybe only one or 0, and you can react on the user's behavior, and print an error message and ask the user to re-enter the data in the correct format. Good. This is basically input, output, and input. So we had, you just remember and keep in your memory that we had a bit strange things here. Most important, the one here, that we are under some circumstances which we still don't know, we have to omit this ampersand. Okay, let's go first. Let's just briefly go over the control statements and then have a deeper look how come the thing with the ampersand. Good. Control statements. So we have selections in C. This is if, totally the same as in C#. Curly braces, and yeah, so I don't want to lose too much time here. You also could write down else if chains, So there you have if, else, if, else, if, else, if, and else. This is no news. Switch again is totally the same. There is no real difference. We anyway so the breaks could be omitted under some circumstances. Circumstances, but this is not a real thing we want to go into detail. So we write it down as we did in C#. We have loops. We have the while loop. We have the do while loop. Remember the semantics of these two types of loops. So this is the head driven loop where the condition is checked before the loop is entered, and this one is the tail driven loop, which goes into the loop at least once, and at the end we check whether we have to redo the loop or not. This is, I think, really a trivial thing to do. And of course, our good old friend, the for loop, is here. Here again, please recall and try to remember how the semantics is. If we come from top, what is executed, and if we come as a second time from the bottom, what part is executed here. Check out, if you're unsure about this, check out the handout of our first year's course on C#. Then there will be also continue, break, exit, and go to, but never ever. We don't use these. Okay, good. Symbolic constants. This is again just, well, you know this already. It increases readability tremendously. If you look into this, if user selection equals 4, is somehow well, we don't know what is this magic number for really meaning. But if we write down if user selection equals change bit to 1, then we read it and we immediately know what we wanted to express with this statement. So how to do in C? It's to be written down as hash define, then the name of the constant, the symbolic constant, and here the value. You see here there is this is another thing with that hash. Maybe you remember hash include to include an external header file. Here hash define. There is also some relation between these two commands. We'll check this out later. It's simply, well, we just remember in C# there was the const keyword. This is in some standards of C already available, but we don't know it. We don't use it simply because there are a few very special things using const, and the define is a simple way to define symbolic constants. Good. Now we're going to the last block, functions and parameters. And so now I can do, or I can fulfill my promise that I will show you the solution of the puzzle with the last ampersand. But first of all, I'll check out functions. You know them already. It's similar to methods in C#, but we have seen already that methods are always coupled to some objects or classes, And since we don't have objects or classes in C, well, there we can't couple them to these things, so they are more standalone entity in C. Well, the way why we're doing functions, you know this, we subdivide our larger problem into smaller problems which are easy to solve, and we can then assemble a few functions to solve a bigger problem. We have to hand over external data via arguments or parameters. You know this also from methods. This is pretty similar. And finally, they can have return values. And yes, this one was already mentioned, that we have lots of similarities to methods. Good. Good. Now we look into how to define our own function, and just go through that. It's pretty easy. It's similar to a main function, and then to any method in C#. This is the name, and here we have one argument. We could have more arguments. Again, you know how to do that. We have a local variable r, which is only known and visible within this block here. We have a return value, so means here we are returning the value of the variable r, and we have to return something because it's an integer, so it specifies that we are returning an integer type here. Well, we have a function header. This is again the same thing as in C#. There it was called method header, and ta-da, a function body, which is taking the or is describing the implementation, whereas the header is somehow the signature where we can read how to use that function. Good. Yeah, we had this already. Function can have arguments, and they have a locals to get the local scope, and to reduce possibilities of interference between different variables. And we have possibilities to do output. So a standard way is of course the return value, and maybe the non-standard way, so to say, is doing pointers to arguments, and this we will check out during the next slides. You know this one, so non-standard way in C# is writing ref or out, and here we have to use pointers. Good. Let's see how a parameter is handed over to a specific function. So let's look into some small code snippet. Maybe in the main function, we are declaring a character user input, a variable user input of type character. We are assigning a, so the character a, to this variable, and then we are calling is valid and hand over user input as a parameter. So what is going on here? Check this out. So we have the main function, and we have the function is valid, and you see already we have the parameter here. It's a character, and we call it user input. So we have basically we have some memory reserved for this variable. Okay, and now let's start. What is going on here? First of all, we are executing this statement. And what happens in main? We will get some variable user input again here. And this has currently an undefined value, so we don't know. There is no in C, this is also important in C, there is no standard initialization, so we have an unknown value. So that's why we give it a specific value, namely the character A. So if we execute this line of code here, we have stored A into the variable user input. And now we go to the next line of code, and this is the call of is valid. So this means we have is valid, and this one is called, and we have, when calling this, we have to hand over user input, the variable or the value of the variable user input. We have to hand over this to our function we call. So what happens is that we take a copy of the value of A, and then this A is handed over to the parameter user input. And if you look into here, if we are somehow changing user input, the variable, the value of this variable, to B, or I don't know, to any other character, there is no relation anymore to the variable user input here in the main function. And that's why we are able to, we can do anything in here, and there is no real effect on our, so to say, original variable. And we call this most of the time really desired behavior. We call by value. So we call this function, and the parameters here are handed over by value. We're taking the value. But there is another way to do so, because we know sometimes it's necessary to get information out of function via, or a method via a parameter, and this one is then called by reference. So just see here again some code. Again, we have a number, so this should be again some snippet out of a main function. We're declaring an integer, we're assigning some value, and then we are calling getVal. And here, again, here we have this ampersand. And we say, okay, this is the ampersand, we understand somehow it has a relation to the ref or out parameter. And so we check out now in detail what really goes on. So here again we have the main, we have getVal, and here you see the first difference. Here we say we have an integer, and there is a small star where we say, okay, this is not a real integer, but it's an address to an integer value, and we call this address input. Good. Now doing, we see, okay, of course, since we have this parameter here, we need some memory. And you see it's a different color, it's not blue, it's green, and you'll see in a minute why this is. So let's go through that. We have a number. The number here you see this is pretty well known. It's blue because it's just a value and we don't know which value it really has. And I add here something. This would also this would also have been in the previous example in the call by value, but there it was not necessary. But here this thing becomes important because of course the value of number is somewhere in the memory, and I just write down here where at which address in the memory the value of number is stored, and we assume some arbitrary value. It's FC47, some hex value determining the address where number is stored. Good. Now we assign a value to number. This is the same as before, and now we have the function call. And the function call, of course, we have this the call itself, and then the following thing happens. So you'll see here again our ampersand, and this says we are not taking the value, but we are taking the address. And we do not copy the value, but we copy the address. And this address is now passed over to get well, and the variable input doesn't have the value 42, but the value FC47. And now we are we could use star input to write something into the variable. So star input, you could say, is somehow acting as a link back to the original place. So this would say that we can somehow in get, well, we can change the original value in main via this link. So this is if we are writing star input equals 17, we would say that we are taking the address stored in here, and we are changing the value of the address. And so here this means we are going back, because here we have FC47 and it takes the value of this address, and so here we go back to the original value, and that's why we could change then the original value of 42 into 17. So that's the secret behind call by reference, and this is also the secret behind this ampersand. Nevertheless, we have still one question open. This is, where was our ampersand gone in the when we had this array of characters? We know already pretty well, for example, scanf needs a pointer, because otherwise it would not be able to write into our variable. But we did not specify pointer here. And the secret behind is that arrays internally are, so identifiers associated with arrays do internally not store the whole array here, but they store the address of the first element. So this means in name we have the address of the first element. This means the character f stored. So this means, or if you see it here, if we have the declaration of given here and the initialization we see here, then we have so when the compiler is running against this one, it has to store this constant into memory. It takes an address that is free, and again in our example it would be FC47, and it stores the F, and then it takes the next address to store the E and the R and the L, and then it stores a \0. We'll see later why this is. This is maybe in two or three units. And we have, since we have 8 characters here, we need 8 bytes. 1, 2, 3, 4, 5, 6, 7, 8. So we would have 3 characters as a kind of buffer we could also use. And this is here, and name itself stores the address of the first character. So somewhere later in the memory we have this identifier name stored and the corresponding address where this string starts. FC47, FC47, this is the start. Okay. Now, you can see, maybe we just try again. You can see here for the scanf that name is already a pointer. This means if we have arrays, and not only arrays of characters but also arrays of integers or whatever other data type, as soon as we have an array, the identifier of the array is an address. And so this is the reason why we don't have to write down the ampersand here. Yeah? Okay, now the question remaining is, so do we have to care? So does it matter whether we write down the ampersand here or not? So just go straight forward with that, what we have seen so far. If we would take the ampersand, then it would not take the value, but it would take the address where this value is stored. This means we would hand over not FC47, where scanf then would start writing in the parts which have been scanned from the user input, but it would take FC80 and it would start here writing the input of the user, which would definitely result in a buggy program. So take care. If we have a simple array and we want to hand over this array, it's always a pointer, and normally it's a bad idea to write the ampersand here, because then we would have our characters or whatever we manipulate. This manipulation would be done at the wrong place. Good. Now that was the really hard part. The rest is pretty easy now. C program is a collection of functions, you know already. So we have a main function, and all other functions, they are alike, so there is no other special function. This is only main, because main is mandatory, because main is the one function that is called if we start our program. We are not allowed to nest functions. This means we are not allowed to define functions within functions. This is again very similar to C#. There we are not allowed to define methods within methods. The scope of an identifier is limited within a function or within a block, so we handled this already. And of course, not all functions have to return a value. If we have a function that should not, we specify a return value of void, again, as we know. Okay, now you can lean back. It was a bit a bumpy ride and lots of stuff here, but we are done. And we have done a lot, of course. So just we summarize and feel well here. Well, we're repeating the basic things here in Hello World. We checked out lots of basic stuff of C and found out that there are some real good similarities to C#, which we know pretty well. We were somehow finding out that call by reference, so means handing over parameters or handing over addresses as parameters, is a bit a nifty thing. But don't worry, we will repeat this over and over again during the next lessons. You will get used to that, and it's simply you can see this as a challenge, because it is something that is much closer to the machine, and if you understand this, you are really one or a big step closer to being an expert in software development. And then finally, after coming over this one and also seeing here in the section where we were looking in function definitions in C, we are now we finished the whole session by looking into a few, again, very trivial things which we know already from C#. Good. Congratulations, you went through this, and as I said already, you made a big step forward in becoming an expert in software development. You understood the first basic things about pointers. If you have still some kind of troubles to have it very clear in your mind, don't worry. Go over that part of the video again and make your exercises, and things will become pretty clear in the next weeks. Good. That's it for today. Thanks for listening, and see you soon with Unit 4.